Welcome back to the philosophy of knowing and being. We're talking about reasoning. We looked at deductive reasoning, and now we're going to dive into inductive reasoning. It turns out we use inductive reasoning quite a bit in our daily lives. In fact, you really can't function in the world without inductive reasoning. But it's different than deductive reasoning. Let's take a look. Inductive reasoning. With inductive reasoning, arguments are intended to be such that if the premises are true, then the conclusion is at least probably true. Now, this is different than deductive arguments. Remember that in deductive arguments, if the premises were true, the conclusion had to be true, necessarily. But contrary to deductive arguments, in an inductive argument, it's at least possible for the premises to be true and the conclusion to still be false. Let's take a look at some examples, common types of inductive arguments. And this is by no means an exhaustive list. And again, I refer you to the notes to see the examples here and to pause if you need to think of these as I go, because we'll move through them somewhat quickly. One common type of inductive argument is generalization. That's inferring that a property applies to an entire class from the consistent observations of that property applying to a sample of that class, right? So, for example, I infer that all crows are black from the fact that every crow I've ever seen is black, right? So, from a small class of crows, the ones I've seen, I notice a consistent property, they're all black, and I infer that that property belongs to all of them. We do this all the time with kinds of things. So generalization. Statistical probability inference. So this is related, but instead of all crows being black, we start talking in probabilities. This is either inferring that a percentage X of the whole of a class has a property from the observation that a certain percentage of a representative sample of that class has that property. Or inferring that a given individual member of the class is a certain percentage likely to have that property from the observation that a certain percentage of a representative sample of that class has that property. So philosophers have to make these things as complicated as possible, but there's a certain precision in that. So that's looking at a general population of persons or things or objects and saying within that group certain percentages of properties arise, and so we can extrapolate from that, we can infer from that any given individual might have a percent probability of having that property. So for example, a market statistician concludes from an appropriate random survey within a certain margin of error, 80% of shoppers at Frank's Foods are happy with the selection of produce there, right? So the statistician doesn't poll every single shopper that's ever been to Frank Foods. He polls a certain small sample. 80% of them are happy, and so he can conclude that 80% of all shoppers are happy. So we do this all the time. Or he concludes that any random shopper at Frank's is 80% likely to be happy with the produce selection, right? So from a sample size, we can conclude to larger population. We have cause to effect inference. We look at a cause and we infer its effect. This is applying a known causal rule, linking a particular kind of cause and a particular kind of effect to an actual situation where one observes that kind of cause and can conclude that we expect to observe its typical effect. So this is, I see a certain cause and effect all the time, cause and effect all the time, and then all of a sudden I see the cause and I infer that we're going to see the effect. So for example, a meteorologist observes a cold front advancing towards a mass of warm, moist air over the Midwest and concludes that there will be showers and thunderstorms tomorrow because in a large portion of cases where he's seen that before, the effect is showers and thunderstorms. We can go the opposite direction. We see an effect and we reason to a cause. This is applying a known causal rule again, linking cause, C, to effect E. We apply that to a particular situation where one observes the state of affairs of type E, the effect type, and conclude that there has been a state of affairs of the type C, the cause, which caused that effect. So we're just going the other direction. So we all the time see cause, effect, cause, effect, cause, effect in the same way. We see the effect and we infer, we reason to the cause must have been there as well. So for example, if one goes to a typically deserted beach and finds a picnic blanket with a basket and plates and silverware set out properly and undisturbed, there's the effect, one concludes that other humans have been on the beach because that's the normal cause of picnics being set up. Or if one sees the world as containing structures that are designed to achieving ends, or goals, one might conclude that there exists an intelligent designer of the world. Right? We see an effect and we move to the cause. Now, notice, by the way, with any of these, I should have probably highlighted this with each of them, but notice the conclusion could be wrong, right? The statistical probability could just not pertain. We might have gotten a really bad sample, right? With the generalization, maybe there's a blue crow somewhere I don't know about, right? Cause to effect, effect to cause. Maybe maybe it wasn't humans who set up the beach for the picnic. Maybe it was aliens. I don't know. The point is these conclusions don't follow with absolute necessity, right? Not the way deductions do. Here's another one, my favorite one, abduction, right? Has nothing to do with aliens, by the way. This is very close to effect to cause, the previous one. A lot of times, though, it's listed separately. There's another video in the series here which talks a little bit about abduction. It's an argument from a state of affairs to its best explanation, right? So we see something and we reason to what must be the best explanation. For example, you arrive home to find your door open with marks of forced entry, the house is in disarray, family heirloom 19th century painting that hung in the living room is gone, as well as other valuables, and you conclude that your house has been burglarized. And that's the best explanation of the state of affairs. So that's called abduction. It's not quite the same as other inductive reasoning. This is actually, maybe I'll mention this in class too, this is often used in Christian apologetics to argue for the resurrection. That given the data of the empty tomb and the appearance narratives to the apostles and the early apostles being martyrs, that the best explanation for those things is an actual resurrection. Argument from analogy. Now, the way my notes are written just complicates this, or it's the precision that philosophers use in their definitions, kind of takes it out of the common way of speaking. So arguments from analogy, again, we do this all the time. Observing that object A or situation S, so observing a thing, that it has properties W, X, Y, and Z, and that object B or situation T, a different object or situation, has properties W, X, and Y, we conclude that object B, or situation T, also has property Z. So if we see one thing, and it has A, B, C, and D, and we see another thing, and it has A, B, and C, we can conclude that it's also going to have D. This is an analogy. For example, Jack's uncle Leo dropped out of high school, bummed around the country for a couple of years, liked to party, and finally started a successful business. If someone were to conclude that Jack, who also dropped out of high school, likes to party, is currently bumming around the country, if we conclude that he's likely also to start his own business, then such an inductive inference would be an argument from analogy, and a pretty poor one at that. Or a watch has precisely formed parts which fit carefully together and perform a useful function, and was, we know, created by an intelligent designer. Some might conclude that an eye, which has precisely formed parts, which fit together, and perform a useful function was likewise created by a designing intelligence. So that's an argument from analogy. And arguments from authority. Given that person P is an expert in a certain area of knowledge or a certain skill, or in some way a privileged observer of certain events, we conclude that P's claims regarding his area of expertise or those events are true. This is, remember, we talked a lot about testimony. Beliefs justified by testimony often are going to use arguments from authority, right? As soon as you bring in an expert, scientists say, that's an argument from authority. 9 out of 10 dentists, right? Argument from authority. Or my favorite one in our household, because I said so. Okay, sorry, thinking of my 3-year-old. Okay, we looked last video at what makes a deductive argument a good one, and we said, well, a deductive argument has to be both valid and sound. It has to have the right logical form, and the premises have to be true. Little different for a inductive argument. 2 senses here, though. One, we can talk about the strength of an inductive argument. An inductive argument is said to be strong just in the case if its premises were true, then the conclusion would probably also be true. All right, so this, remember, the premises don't necessitate the conclusion, but to the degree that it would probably be the case that it would be true, that's how strong it is, right? Examples, let's see, not yet. Examples of strong inductive arguments. Things like, we've sorted through the first 20 apples in this crate, and 10 of them are bad. And we conclude that very likely half of the rest of the crate will be bad as well, right? So we've sorted through the first 20 apples, half of them were bad. We conclude that it's very likely that half of the rest of the crate will be bad as well. That's a strong inductive argument. Or how about, it snowed in Mississippi at least once in late June every year for the last 50 years. Now follow me on this one, right? It has snowed in Mississippi at least once in late June every year for the last 50 years. We conclude that it's very likely to snow in June again this year. Now notice, this is a strong inductive argument because if the premises were true, then the conclusion would probably follow. The fact that the premises is false means that, while a strong argument, by our definition of strong, it's not what we'll call a cogent argument, which we'll explain in a moment. So this is kind of parallel, it is parallel to valid and sound in deductive arguments. Instead of valid and sound, we have strength and cogency, right? So a deductive argument is valid based on its structure, that if the premises are true, the conclusion necessarily follows, right? An inductive argument is strong that in the case that if the premises are true, it's likely, or it's probably the case that the conclusion will be true as well. Now, before we get to cogency, there are issues of defining what counts as a strong inductive argument. In fact, in my other ones, you might have said, well, I don't know, maybe 20 apples wasn't enough. Maybe you need to look at 30 for it to be really strong. What if I said we looked at 2 apples and one of them was bad, therefore we can conclude that half of the rest of the crate will be bad? Well, you might say, well, that's not a very strong inductive argument. So there's some questions. What qualifies an inductive argument as strong? It's far more difficult to offer general rules defining what it is that constitutes the strength of an inductive argument than it is to define what constitutes a valid deductive argument. However, one of the overarching principles supporting all inductive arguments is the uniformity of nature principle, right? We have to almost either argue for or assume the uniformity of nature principle. This principle roughly states that the regularities of the past will continue into the future, right? So I've consistently seen only pink flamingos, right? The the regularity of nature principle states that it's very, 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 very unlikely that tomorrow all flamingos will suddenly be green, right, or change to the color green, or every time I've dropped a book out of my hands, it's fallen to the ground. It's very, very, very unlikely, according to this uniformity of nature principle, that the law of gravity will somehow be suspended tomorrow. Beyond that, defining what would count as a strong inductive argument gets very complicated, given the enormous variety of kinds of inductive arguments. Still, our intuitions are fairly good at determining the strength and weakness of any given inductive argument if we keep an eye out for the common fallacies that we're going to discuss in another video. So you might say, we could all probably agree that, oh, I've looked at 2 apples, one of them was bad, or I'll give you a better example. Oh, I looked at 1 apple, it was bad, let's throw out the whole truck. We all go, well, that's not a very strong inductive argument. But we might disagree on how many apples we'd have to look at for that to be a strong inductive argument. Okay, so strength has to do with if the premises are true, it's very likely that the conclusion will also be true. But we can also talk about the cogency of an inductive argument. An inductive argument is said to be cogent if, in addition to being strong, the premise or premises are also true. So this is like having a sound deductive argument. For example, it is very rarely, if ever, snowed in late June in Mississippi. Therefore, it's very unlikely that it will snow in Mississippi in late June of this year. So remember the previous one, I talked about it actually snowing. My example in the previous one was it snowed in late June for 50 years, the last 50 years in Mississippi, right? Well, that's not true, so that wasn't cogent, right? This is cogent. It is very rarely, if ever, snowed in late June in Mississippi. True. Therefore, it's very unlikely that it will snow in Mississippi in late June of this year, right? So that's probably a strong argument, and it's definitely, I believe, cogent, unless you can show me that I'm wrong, that it snows in Mississippi in late June. Okay, but, nope, I don't want to go that far yet, but it's not enough for the stated premises to be true. That's a step, but there's at least one other thing you need to check in an inductive argument. The set of premises of the argument must meet the total evidence requirement, right? The total evidence requirement, which demands that all relevant evidence be taken into account when one attempts to draw the conclusions. If this is not done, then while the individual premises might be true, they would not together cogently support the conclusion, because the set of premises excludes or overlooks evidence relevant to justifiably drawing the conclusion. So, for example, consider this argument. It's 85 degrees and sunny in Ocean City. The water temperature is comfortable and the sea is calm. Conclusion, it's a perfect day for a swim. Right? But supposing there were several ominous dorsal fins seen breaking the surface of the water. The argument is strong because of its premise, because if its premises were true and complete in their taking into account all relevant evidence, then the conclusion would most likely follow. However, the total evidence requirement has not been met because evidence importantly relevant to the conclusion, that is, sharks swimming about, has been overlooked or ignored. And this is another piece of, when you look again at, I don't want to pick on politics, but it happens to fit well, political discussions and debates and media and commercials, a lot of times relevant evidence is left out. And we tend to do this ourselves when arguing for a point. We intentionally or unintentionally leave out relevant details that aren't too good to our arguments, right? So we have to look for not just we have to look for evidence that might be left out. Speaking of problems with arguments, in our next video we'll look at logical fallacies.